going to shut down on me. Perfect timing. There it goes. Let me get that back up. You may see 30, 60, 90, but if you need to solve for the side, you could just use SOHCAHTOA, right? So not a big deal. All right, sorry guys. Let me get this back open. Review for tests. There it is. Boom. All right, so here's what we can expect. You guys already know it's 5-word problems, no multiple choice whatsoever for this test. It's going to have Hills and SAS, which goes way back to day 1 and day 2 of this unit. We're going to do a review problem of that in a second. SOHCAHTOA, all good. Angle of elevation and depression. Let me just go over that real quick so we remember where those angles are. All right, elevation's on the ground looking up at something, building, tree, whatever the case is, and that angle is right there. That's your elevation angle. No issues. That's always on the ground looking up. Depression is not inside the triangle. It is not this other angle. It is on the outside of a triangle. So you're on top of the building or the tree looking down. This is the angle of depression. And we talked, I can't use it in sine, cosine, tangent. How do you get that angle of depression inside the triangle? How do I move it inside now? One of two ways we talked about. How do I move the angle of depression inside? Gianna? Subtract 90 from it and you get the angle adjacent to it, or say it's congruent to its alternate interior angle. Okay, either way. All right, to get it inside, but depression is located outside the triangle. You will have to use law of sines and cosines. We spent the last 3 classes on that, but I'm not going to give you the formula. That's up to you. Reminder, this can be used on a right triangle or a non-right triangle. All right, you can put, if you're using law of sines, it's okay to put sine of 90 down there. Okay, it's okay. All right, so it can be used on a right triangle or a non-right triangle. And here's the breaking news here. I didn't want to blindside you either, but one of the 5 questions revolves around one of the figures from the parallelogram family. Parallelogram, rectangle, rhombus, or square will be asked. And you will need to know their properties to do the problem. Okay? Well, that's not fair. That was before the midterm. Don't take honors math then. That's my cold-hearted way of my response. All right? So one of the 5 problems involves parallelogram, rhombus, rectangle, or square, and you will have to use their properties to move along in the problem, right? To move along. So there you go. There's the test tomorrow. All right, 5-word problems. They're going to be a little bit longer and involved. Am I saying that they're always going to be like 2 or 3 steps? No. 1 or 2 of the word problems might be do it one way and you're done. But it might also be I got to find this side to get to this side as well. So, questions about tomorrow? All right, I'm going to first let's talk about, like we always do. If you go to page 55 in your review packet for me, page 55, there is no Delta Math. There's no extra review on Classroom. All I have for you is what's in the packet, which is pretty darn good too, by the way. Not because I made it up, but I feel like what's in the packet kind of resembles the difficulty level of what you'll see tomorrow. Okay, are you going to see 5 huge word problems in your review packet? No, but your review packet does have some questions you're going to have to think about like tomorrow. And also in the oval on page 55 down below are textbook questions. So that's what you have to practice from. Everything in the packet and textbook questions. All right, good. And all the answers are in the back of your packet. That's probably why the packet is so darn thick, because we had to duplicate the review and just put the answer key there. All right, I need you guys to go to, this is problem 11 for me, please. I do want to just re-expose you to a topic we did at the very beginning of the unit to make sure we're solid. Okay, number 11, if you just look at the diagram by itself, we should before we even start putting down a number, a proportion, or anything, we should know what type of problem this is, just by the diagram. I got a right triangle here, and look what I'm doing. I'm drawing an altitude to the hypotenuse. Makes this what type? Boom, right away. Hill-SAS, done. All right, Hill-Sass problem before I write down any numbers or calculations. So now the question is, which one is it, right? Which one is it? And the way you answer that question is the altitude involved? Is the altitude, do I have to find it or is it labeled for me? No. So there's no way I can use SAS. I'm not going to have enough information because the altitude's not involved. It's going to be a Hills problem. All right, so can you quickly review with me? H in Hills stands for hypotenuse, and that is hypotenuse of the large right triangle, which would be 12. L for leg, and there's two of them in the diagram. All right, I got BA and I got CB, but we're looking for CB, so that's the one I want to use. Other L, same leg. Means are always the same. And then S for segment. We got two of them. We got DA is 8, and we got CD. Which one do I want to use? The one adjacent to the leg in the problem. So even, I know 8's convenient to put because I gave it to you, but I don't need 8. I need the segment adjacent to the leg, CD. So I'm going to put a 4 there instead. And now we cross multiply. X squared equals 48. And the directions do say simplest radical form, so we're going with x equals 4 radical 3. All right, questions? So just, again, that's not the only Hill-Sass problem in your review, but I just wanted to re-expose it to you, and you'll certainly see it again on one of the big 5 problems tomorrow. I know some of you probably have already done it, but I do want to go over question 1 with you, just to make sure we're good on how to find an angle. Speaking of quadrilateral properties, here's a quadrilateral. Rectangle has a length of 8 and a width of 6. So you can put the 8 and the 6 anywhere you want. It's not going to matter. I'll just make mine look to scale. And we're going to draw on a diagonal and find what angle it makes with the longer side. The longer side. So we're talking the side of 8. So even if your diagram differs from mine, it's fine. We're still looking for the same angle, which is the one the diagonal makes with the side of 8. Just if you can, keep it in mind tomorrow. Oh, he's asking for an angle. He's asking for an angle. So no matter what work I put up here, at the end I'm going to be doing what? Arc, right? Arc, cosine, sine, tangent, the shift key. All right, whatever the work is here at the end, I better be hitting that shift key to find my answer. All right, so what do I need? Arc, sine, cosine, or tangent? Right, rectangles have right angles. And now you're going to determine what the 6 and the 8 are. We know opposite sides are equal. All right, little help here. The 6 is what from the angle I need to find? Opposite, adjacent, hypotenuse. Opposite. 8 is adjacent, so we're going to be using which ratio? Tangent, yep. So tan of x equals opposite over adjacent, and I don't cross multiply. That is the ratio you need for arc tangent. All right, so there it is. No cross multiplying when you find an angle. So I'm going to go arc tangent 6/8. And it'll give me, what's this one, 31 or 37? 37. And last thing, and then I'll let you go on your own. When you look at my answer key, all right, this answer key has been done over the last couple years. Remember, this is my first year using the NumWorks. So for instance, if you were to check number 1 on the answer key in the back of your packet, you'd see this notation to the -1. That used to be with the TI calculators we used to use. All right, that anytime you see it to the -1, that's arc. Okay, so this is arc tangent. All right, so just, I don't want you to be freaked out. What does that mean? That's arc. All right, that's what we used to use when we used the TI graphing calculators, but we use these now that have arc on it. All right, arc tangent, arc sine. So if you see the -1, That's what that's all about. All right, don't freak out. All right, I'm good. That's about it. Any questions from you guys you ask as you do the problems? Get after it. I don't want any excuses tomorrow. Okay, no excuses tomorrow. This is a big one, just because of the time we spent on it.